Hello, friends. Take a quick look around you. Your phone, your laptop, the Wi-Fi keeping you connected, even the smartwatch on your wrist. All of them are doing one thing underneath the surface. They're computing. But what does that word actually mean? What is computing, really? And why is it worth taking the time to study it in 2026 when the tools mostly just work? In this video, we're going to answer exactly that. What computing is, where it came from, and why understanding it changes the way you see almost everything around you. Let's get into it. All right, let's start with the simplest possible definition. Computing is just the act of taking some information in, doing something to it by following a set of rules, and producing new information out. That's it. Input, process, output. When you type a message, the keystrokes are the input. When your phone runs the rules that turn those keystrokes into a sent message on WhatsApp, that's the processing. And the message appearing on your friend's screen is the output. Every single thing a computer does, playing a video, running a game, recognizing your face to unlock the screen, is just a more elaborate version of this exact loop. The rules get more complex, the inputs get richer, but the core idea never changes. Now, here's something most people miss. Computing is way, way older than the machine sitting on your desk. Long before electricity, humans were already computing, using an abacus to track grain in ancient markets, doing long division by hand, even working as professional computers. That used to be a job title. Rooms full of people, mostly women, manually crunching numbers for astronomy, navigation, and later ballistics during the World Wars. Then came the mechanical era. Gears, levers, punch cards. Charles Babbage designed an engine in the 1800s that could, in theory, run programs, even though it was never fully built in his lifetime. The electronic computer, the thing we now just call a computer, only shows up in the 1940s. So the word computing describes the activity. The word computer describes the tool we eventually built to do it faster. Keep that distinction in your head. It'll matter in a moment. Here's the idea that changed everything. In 1936, a mathematician named Alan Turing asked a strange question. Could you build one single machine that's capable of doing any computation as long as you give it the right instructions? Not a separate machine for math, another for sorting, another for drawing. One machine, infinitely flexible. And he proved, on paper, that yes, such a machine could exist. We call it a universal machine. And that's exactly what your phone and your laptop are. The hardware doesn't change when you switch from watching YouTube to editing a photo to running a chess engine. The same chips, the same memory, the same wires, just running different instructions. That's why one device in your pocket can replace a camera, a calculator, a map, a TV, and a music player. The hardware is universal. The software is what tells it what to be at any given moment. Hold on to this idea, because it's the foundation everything else in computing rests on. So if computing is the activity, and a computer is the universal machine that performs it, then every computer is built from two halves working together. On one side, you have hardware, the physical stuff, the chip doing the math, the RAM holding things temporarily, the SSD storing your files, the keyboard taking your input. You can drop it, you can hold it, it has weight. On the other side, you have software, the instructions, pure information. The operating system, the apps you open, the code a developer writes, even the YouTube video streaming right now. Software has no weight. It's just patterns of ones and zeros telling the hardware what to do next. Here's the part that's worth pausing on. The hardware is what does the actual work, moving electrons, flipping switches billions of times a second. But the software is what decides which work gets done. Without software, your phone is just an expensive piece of glass and metal. Without hardware, software is just an idea written down somewhere. Computing happens in the gap between the two, when instructions meet the machine that can execute them. Now here's what makes modern computing actually possible. Layers. When you open Instagram and scroll through a reel, you're not directly poking electrons in a chip. You're tapping an app. That app is built on top of an operating system. Android, iOS, Windows, Linux, which manages everything underneath. The operating system itself is written in programming languages like C or Rust. Those languages get translated down into machine code, which is just numbers the CPU understands. Those numbers get executed by logic gates, tiny circuits that do simple operations like and, or, and not. And those gates are built from transistors, physical switches, billions of them, packed onto a fingernail-sized chip, flipping on and off based on the flow of electrons. Each layer hides the messy details of the one below it. The app developer doesn't think about electrons. The chip designer doesn't think about Instagram. That's the trick that lets billions of people build and use software without needing to understand physics. And the deeper you go down the stack, the closer you get to what computing actually is, underneath all the polish.
Okay, so why does any of this matter to you right now in 2026? Because computing stopped being something that happens inside a beige box on a desk a long time ago. Your car has more computing power than the spacecraft that landed humans on the moon. Your microwave runs code. Your watch tracks your heart rate using algorithms. Traffic lights coordinate using small embedded computers. Hospitals run on databases. Banks move trillions of dollars a day across networks. Airplanes essentially fly themselves. The cloud, which is really just someone else's computers in a warehouse, quietly powers almost every app on your phone. And on top of all that, AI systems are now writing code, generating images, and answering questions in ways that would have looked like science fiction a decade ago. Computing isn't a separate field you opt into anymore. It's the background layer of modern life, which means understanding it isn't just useful for engineers. It's basic literacy for living in the world we've built. So that brings us to the real question. Why study it? Why bother going past the surface when most tools today are designed so you don't have to? 4 reasons that actually matter. First, it teaches you to think clearly. Computing forces you to break fuzzy problems into precise, logical steps, and that skill spreads into everything else you do, from arguing a point to planning a project. Second, it lets you build real things. Once you understand the basics, you stop being just a consumer of technology and start being someone who can shape it. A small script can save you hours. A small app can reach millions. Third, it lets you see through the magic. The recommendations on YouTube, the autocorrect on your keyboard, the way your phone unlocks the moment it sees your face, none of that is magic. And once you understand the mechanism, the world stops feeling mysterious and starts feeling buildable. And fourth, it keeps you future-proofed. Languages change, frameworks come and go. AI is rewriting parts of the industry as we speak. But the underlying ideas, how memory works, how networks talk, how problems get solved with algorithms, those don't expire. Learn the fundamentals and you can adapt to anything that comes next. And that's exactly what this channel is built to do. On Compyra, we're going to walk through computing the way it actually fits together, not as a pile of disconnected topics to memorize, but as one connected story. We'll cover programming, how to actually think in code, not just write it. We'll go into computer architecture, what's really happening inside the chip when your program runs. We'll explore operating systems, the invisible manager that keeps everything running smoothly. We'll dig into networking, so the internet stops feeling like magic. We'll work through data structures and algorithms, the toolkit every good developer reaches for. We'll touch databases, security, and the fundamentals of AI and machine learning. And along the way, we'll look at the history and theory behind all of it, because knowing where these ideas came from is what makes them stick. Each video builds on the ones before it, so over time, the whole picture starts to come into focus. So that's what computing is, and that's why it's worth your time. It's the activity of turning information into more useful information by following rules. It's older than the machines we built to do it. It runs on layers stacked on top of layers, all the way down to electrons flipping through tiny switches. And it's quietly running almost everything around you. The good news? You don't need to learn it all at once. You just need to start and stay curious. That's what this channel's for. If this video helped you see computing a little differently,
hit subscribe and turn on notifications so you don't miss what's coming next. We're going to take this one concept at a time, build it up properly, and by the end of this journey, you'll look at any piece of technology and actually understand what's going on underneath. See you in the next one.